Hey everyone, Walter Haydock here. Welcome back to the Deploy Securely podcast, where I go deep on cyber risk management for AI systems. Today, I'm going to be laying out part one of the artificial intelligence risk scoring system. So, to begin with, vulnerability management is already a mess, and AI is going to make it worse. I explained why in the previous episode where I talked about the cybersecurity and infrastructure security agencies' proposals for how to deal with this problem. And I was critical of their proposal because they suggested that AI developers and engineers should build a system that resembles the common vulnerabilities and exposures regime, which is already used for software products on the market today. While the CVE and National Vulnerability Database, or NVD, systems can be salvaged, in my opinion, with some major reforms, there are structural problems that make their current incarnations really a bad fit for AI systems. After thinking more on the topic, I also decided that being able to communicate about the risk of an AI model, more than just identifying individual vulnerabilities in it, was the critical security task. Security teams can spend all day running vulnerability scans and providing reports of vulnerabilities to stakeholders, but that doesn't really move the ball forward too much. So, thus is born the Artificial Intelligence Risk Scoring System, AIRSS, pronounced like the plural of air. And in part one of this series on the model, I'm going to lay out exactly what's in scope and what's out of scope so you can use it appropriately. So the AIRSS allows you to evaluate the confidentiality, integrity, and availability of data impacts to and from artificial intelligence models. It's a tool for evaluating the model itself, not any of the supporting infrastructure. So, not every attack involving or potentially impacting an AI model is covered. For example, known vulnerability risk in the model's infrastructure can be evaluated using the Deploy Securely risk assessment model, which I've published on my blog previously and provided some tools for how to use it. And then phishing or insider threat risk can be evaluated using the factor analysis of information risk method, which I am not the author of, but am a big fan of and really support the quantification efforts that the FAIR Institute have been making. The good news is that the outputs of all of these models are in a fungible unit, dollars per year. If you're using these models to calculate different types of risks, you can add them all back together at the end to come up with a single common unit and single measure of risk. So if you have a mutually exclusive and completely exhaustive mapping of all your cyber risks, you can plug in the AIRSS wherever it's appropriate, for example, where you're using AI models. So with that said, I'm going to talk about some of the potential attack vectors as well as the common data attributes that might be affected by these attack vectors. I'll start off with prompt injection. That's a pretty common one, and it's clearly a threat when it comes to data confidentiality, as it could potentially force a model to reveal information, whether it be trade secrets, personal data, etc., in violation of its security policy. Additionally, if the model is calling a function, a malicious prompt could impact the desired output and interrupt the execution of that function in a way that the designer of the system did not intend. And then additionally, providing a prompt that forces a model to respond with undesirable or inappropriate content, for example, how to build a bomb, could also violate its security policy. And these two examples would be data integrity impacts, as well as potentially confidentiality impacts. So prompt injection can impact both the C and I legs of the CIA triad. Something else to consider are sponge attacks, which are potentially overlapping in some ways. And these attacks try to waste energy or spike latency in the model. So it could be as simple as forcing a company to waste money on OpenAI credits through specially designed prompts. And these types of attacks can have serious real-world consequences by reducing the availability of the model through resource exhaustion or economic exhaustion in the API credits example that I gave. Another potential example of attacks covered under the AIRSS are inference attacks. And these are similar to prompt injection attacks in that they try to extract information from the AI system in violation of its policy. This is a little bit different because they are directly targeting the underlying training data of the model or the model itself for that matter. Perhaps its weights or other characteristics of it that might be confidential and that the designer of the model wouldn't necessarily want to be public. And since certain proprietary AI systems can be quite valuable, losing control over this information, this intellectual property, can have substantial economic consequences for the organization. Another confidentiality-related vulnerability is sensitive data generation. And this occurs when the model aggregates disparate pieces of information that, by themselves, would not violate the model's security policy, but together they can create an input that does. This doesn't necessarily require malicious intent on the part of anyone, but it can certainly lead to a data breach if the model, for example, one, were to aggregate biographical information about a person, his neighbors, and other data to return something that constitutes personal data about that individual. For example, if an LLM knows that my social graph intersects with people living on a certain street, if it knows how many people are in my family, it could potentially intuit my precise street address if prompted. And if someone else were to ask the model for that information about me, that could certainly be considered a data breach. From a different perspective, if a model combines information from a company's knowledge base, which would be otherwise approved for public consumption, that somehow reveals confidential or proprietary data about the inner workings of the company or its products based on inference, then that could also be an example of sensitive data generation. So I'm going to pause here for a word from our sponsor, which is StackAware, my company, in case you were wondering. As you might know, I really enjoy discussing AI-related cybersecurity, compliance, and privacy risks, and I'm now helping organizations identify and mitigate these things throughout their networks. So if you're interested in setting up an assessment, please head to stackaware.com. You can get all the details about how these assessments run, what the requirements are prior to beginning one, and you can also get some case studies on organizations that I've helped previously, like Cobalt Robotics, Reputation, and Encore. So all of these companies have improved their AI-related security posture after a StackAware risk assessment. So if you want similar results, then please head to stackaware.com and set up a call. Thanks a lot. Back to the show. So another potential vulnerability that is covered by the AIRSS is data poisoning. In data poisoning, an attacker modifies the outputs of a model in such a way that it violates the business requirements or security requirements by corrupting the underlying training data. So this could occur before or while the model is operating in production. For example, ChatGPT trains on user input by default, so it's conceivable that a user could provide poisoned data to ChatGPT on which it trains and eventually begins providing incorrect responses. It's important to note that the AIRSS does not describe or address the likelihood of data poisoning happening, because that would be outside the scope of the model, but rather the data integrity and availability risk posed by a given poisoned model. So just want to separate those two things. Finally, another risk that I haven't talked about a lot because it's somewhat outside the scope of deploy securely, but I'll get to it here, is that of malicious AI. So the AIRSS does provide a way to measure the risk of this phenomenon because it compares expected versus actual outputs and weighs the impacts if the latter are incorrect. So the AIRSS can help you measure the risk of a malicious AI, one that intentionally, whatever that means in the context of a non-living object, provides information that is incorrect. So, for example, when GPT-4 reportedly misled another human into believing it was a vision-impaired person, it was providing corrupted data, which is an integrity impact, which can be evaluated by the AIRSS. All right. So now I'm going to discuss some things that are out of scope of the AIRSS. So infrastructure availability is definitely one of those things. Anything related to the availability of an AI model supporting tech stack is out of scope. That's because a pure denial of service effort or encryption by ransomware wouldn't attack the functionality of the model itself, but rather the code supporting it. Similarly, if you simply bombarded the model or the app with queries, that would be out of scope because the problem's at the business logic layer, not the model itself. This would be a little different than if you engineered a prompt that by itself caused resource exhaustion. That would be within scope of the AIRSS, but just a pure bombarding of queries would not be covered. Model poisoning is also something that's not covered. This is slightly different than data poisoning because it's simply a type of software supply chain attack where someone seeds a corrupted component into a larger application. So, for example, when the company Mithril Security successfully uploaded what they called a lobotomized large language model to Hugging Face, this situation would be excluded from consideration by the AIRSS. Although you could evaluate the risk posed by the model in production in a certain system using the AIRSS by treating it as a case of data poisoning. Something out of scope as well is unintended training. Because with unintended training, the model is behaving exactly as one would expect, albeit not necessarily how the user would want it to, this security risk is outside the scope of the AIRSS. I would recommend evaluating this using the unintentional insider threat approach recommended by the FAIR Institute. All right. Thanks for listening to me lay out the foundation of the AIRSS. Over the next few episodes, I'm going to go more in depth on exactly how to apply this in the real world. Next up, I'm going to address business and security requirements so you can more effectively determine exactly what is a vulnerability and what is just normal functioning of the model. And later on, I'm going to get into some hard numbers and explain how you can come up with quantitative measures for AI risk. Really appreciate you taking the time to listen. And please like, comment, and subscribe to get future episodes of the Deploy Securely podcast. Thanks a lot.